Hey everybody. To finish out our plate tectonics, we're just going to kind of review the different types of plates, their movement, and how they result in the lithosphere and what you get from those. So we're going to kind of be finishing up everything that you've been going through for the last couple of days. On the assignment, it says you'll need to make a copy, either an e-copy or a hard copy of the file, and the file at the top has this chart, and on the bottom part it has this map. So we're going to kind of take a look at those, and we're going to kind of start off just to think about what our Earth is looking like. You've already learned that we have an inner core, an outer core, the mantle, and the mantle is kind of broken up into the upper mantle and the lower mantle. And then you have your continental crust and your oceanic crust is the things that we were talking about. And the continent and the crust here, the crust and all the way to the upper part of the upper mantle makes up your lithosphere. And then right below that is the asthenosphere. And in the asthenosphere, that's where the magma in the mantle starts to warm up. And as it starts to warm up, it becomes less dense and it moves this way. And as it cools off, it starts to come back down around, moving this way. And it does that all around in the asthenosphere, making those kinds of convection currents as it's going. And what that does is that drives our plate tectonics. So we have all of these cycles and these convection currents that are going around. So when you have, let's say there's a boundary that's right about here, and you've got convection currents pulling them apart, you're going to have your diverging boundaries. Then when they're coming together, you'll have your converging boundaries. And then when they're kind of sliding past each other, that's when you end up having your transform boundaries. So go ahead and grab this sheet of paper or get that one ready to go. We're going to talk about what happens with these boundaries and everything when these different plates all come together. So just kind of reviewing. Divergent meaning as in divide. They're going to be going like this. They're going to be spreading apart. So those are going to be, they will be pulled apart. And what you're going to end up getting is you're going to end up getting a trench or what they call a ridge, because the magma will flow up in between where the two plates are moving away from each other. Magma will come up and fill in between. And so what you end up getting a lot of the time is new crust. So we want to make sure that we get a trench, we get a ridge, or we get new crust. Very new crust. Usually that happens around in the ocean. Most of that happens there in the oceans. Okay? So then we have converging. Converging is where they're going to be coming together. They're going to converge on each other. I always think about this as when I ask people, I say, okay, divergent, convergent. People always go, oh, I remember those movies. Well, yeah, in the first movie, the Divergent, they were all in different factions, so they were spread apart. Here, they kind of converged together. They started working together. So we get converge here. Now, what happens with converging plates is it depends on what kind of plate you're going to have. If you have an oceanic plate, now remember, the oceanic plate is much more dense, coming up on a continental plate. Oceanic plate coming on a continental plate. One of them, the more dense one, is going to kind of slide under. It's going to slide under the continental plate. So they're going to collide, coming together, and one will slide under. And it's the more dense one that's going to slide under. And what you end up getting is you end up getting a subduction. Now think about submarine. Sub goes under, subduction, one goes under the other. Now if it's an oceanic plate and a continental plate coming together, the oceanic plate will slide under the continental plate, and it'll cause some cracks and things in that continental plate. And what begins to flow up through and fill in those cracks? But the very hot magma, and that will create a volcano. So you're going to get a volcano when you have a oceanic and a continental. It's like when the Pacific Ocean plate and the North American plate come together in Washington State. We have Mount St. Helens, which is a volcano that's there. Oh, gracious. Sorry for the yawn. It's almost 10:30 at night. I shouldn't be doing this. Anyway, then you got an oceanic plate and an oceanic plate. Well, if you've got a dense coming to a dense, they're going to collide. One is going to slide under, and it's going to be the one that is more dense. One will slide under, and of course, you'll end up getting a subduction. But then you get a volcano that's completely surrounded by water. So I get a volcano that is surrounded by water. So what I end up getting is a volcanic island or an island change. Remember, an island is completely surrounded by water. We have these out in the Pacific Ocean, and that's Hawaii. Now I got a continental plate and a continental plate coming together. These are two less dense plates. Thinking about, think if you got two big old garbage trucks, and those big garbage trucks are totally empty, full of air, just air, and they come together, they're going to collide. These guys are going to collide, but the one's not really going to go under the other. They're just going to kind of hit each other and then begin to kind of just crumple, and they're going to fold. It's going to make a lot of folds and push at each other. They're kind of like crumple, fold, make wrinkles, as they call them. And what this actually creates is a mountain chain or mountain range. Okay, so if you got two continental plates coming together and they start to just kind of rumple and wrinkle and fold, then they start to come up and they make that mountain range. Okay, with a transform plate, that transport plate, I got one going in one direction, I got the other going in the other direction. They're going to kind of try to push past each other. It's like those big old dump trucks going down an alley, and they're pushing past each other and they get stuck. But they keep pressing on the gas. One presses and they're trying to go this way and they're trying to go this way, and they're just pressing, and they're creating a lot of tension. And then all of a sudden, so they're going to be coming together. They're going to slide past each other in opposite directions. And so the buildup of a whole lot of tension, they're going to build tension. Then there's going to be a release. Once it slips, when it slips, it releases a whole lot of energy, and that energy is vibrations, and what you end up getting is an earthquake. And so out in California, we have a lot of those with the earthquakes, okay? So divergent is going to pull apart, convergent is going to come together and meet each other, and then though that transform is going to slide past each other, and they're going to cause a lot of tension. Now when you're looking at the map here, if you have it on an electronic file, it's going to be really hard to do this, but if you have a hard copy, it's perfectly okay. But what we usually do in class with this is that we look at and we get three different colors. So I'm going to go divergent boundaries, and then I'm going to have convergent boundaries, and then I'm going to have, let's say, transform boundaries, right? Those are three different kinds. Right. So what I'm looking for is those divergent boundaries are the ones that are going to be pulling apart. So if you look here, these are the dark lines. Now, if you notice this, you notice this is North America. Well, that's great. This is the continent part. This is the oceanic part. And right about here is North Carolina, as you can see that. Okay, so right smack dab about here in the middle of this particular plate. And here's the boundaries of those plates. So boundary D is the North American plate. Okay, so here if I look at C, and where is C? C is the Cocos plate, kind of small one, and F, the Nazca plate. Well, if you look right here, I got an arrow going that direction, an arrow going that direction. So this is going to be a diverging plate. Okay, arrows going opposite each other here. This one's going to be kind of a diverging plate as well. Now, as this one's, it's all moving this direction. This one is also a diverging plate. So I'm kind of going through and marking which ones are the divergent and which ones are the convergent plates right here. So it's kind of, I go, well, wait a minute, what's over here on this side? Well, if this is pushing this way and this one's pushing this way, then obviously that one has got to be a converging plate, right? So we're going to have a converging plate, okay? Now, do you see any of the plates on here where they're actually going back, they're going to be going in opposite directions? So remember the transform goes like this. The divergent goes in opposite directions, pulling apart, and then the converging comes pushing together. So do you see anywhere here? Now, if you go right up here, right along Mexico and California, you've got a transform plate, and it goes on all the way up to Alaska. Well, where do you know? Where do you know that there are lots of earthquakes? There's lots of earthquakes in California, major earthquakes in Mexico, been several earthquakes in Alaska. Well, this is the reason why. We know that there are earthquakes over in Japan. So somewhere over in here, you're going to find that there is going to be a transform plate right up around through here where Japan and everything is going to be. So you're looking at divergent that are pulling apart. That's going to create trench and new crust. You're looking at convergent, which are coming together, and depending on what kind of plate they are is what's going to be created. And then you've got your transform plates that are going in opposite directions. They kind of snag up on each other and end up creating a lot of tension. They slip, a release of energy, and creating an earthquake. Okay? I'm going to try and make another video of a lab that we usually do. It's a lot of fun. I would much rather be doing it in class with you because we get to do it with Jell-O and graham crackers and eat. But for right now, we got these things. So go ahead and finish up your tectonic plate chart and finish in, see if you can kind of color code in your map where there would be more divergent, more convergent, and more transform. And I'll see you on the next video.